Hi guys and welcome. Today we are doing grade 12 maths paper 1 and we are looking at question 7 from the November 2025 paper. Okay, so question 7.1 reads, a travel company informs Robert that a holiday to a certain destination costs 40,000 Rand now. The company predicts that the cost of this holiday will increase by 7.8% per annum. What will this holiday cost in 5 years' time? So the amount is going to equal your P, your present value, 1 plus I to the power of N, because it's increasing annually. So that will be compound. Okay, so our present value is 40,000. Our interest is going to be 7.8%. Now you can write this as 0.078 or 7.8 over 100, or you can just say 7.8% and let your calculator do the work. I think that's probably the safest bet. And now we stick this into our calculator, 5823094. Okay, so let's go on. Okay, now if you would like to do this paper together with me from the beginning to the end, I've put all the videos in a playlist, as you can see here, starting from question 1 all the way to the end. So what I would suggest you do is click on the link in the description or in the comments. I'll pin a link to this playlist so that you can start from question 1 and work your way through to the end. And I think that that is going to be excellent preparation for your paper 1. Okay, so 7.2 says Sarah opened a savings account that paid interest at a rate of 5.8% compounded quarterly. So let's just put in our I now. So I is equal to 5.8% divided by 4. You can write 0.058 or 5.8 over 100, but this one is a bit safer just because the calculator handles everything. And so, for example, some students write 0.58 instead of 0.058, especially under exam pressure. So, yeah, I just like to use the percentage button. The amount, the payments is 2,300 and pays into the account on the 1st of January and continues to make payments at the beginning of each quarter. Very important, this beginning of each quarter. Okay, and I'm going to explain that now, why that's so important. She made her last payment on the 1st of October, and then we want the accumulated amount on the 1st of January 2026, right? 2026. So notice that it goes from the last was the 1st and then it goes to January. So that's an extra quarter, right? October, November, December. So that's important. And I'll explain to you why. Because when you look at this future value, so this annuities formula, this is for when payments are made at the end of each period, okay? So for example, if it's monthly, the payment is at the end of each month, or quarterly, the end of each quarter. So if they say the beginning of each quarter, like they have there, okay, beginning, let me underline that in yellow. Then we need to give it an extra amount of interest, okay? Because beginning of the period, you must just add on this extra interest. Okay, so very important. They normally do these questions at the end of each period. This was a tricky year where they did it at the beginning, and that may have caught a few students out because beginning of the period. So the 2,300 was the payments, that's the X. Then it's 5.8% compounded quarterly. Now, what are the years? What's the N? The N is going to be from 26 to 2020. So if you think all the quarters in 2020, that's 4. 2021, 8. 2022, 12. 2023, 16, 2024, 20, 2026, 2025 is 24. Okay, so you could just say 26 minus 20 is 6, and then 6 times 4. But yeah, I just wanted to go through that. 6 to 2020. And then we are going to put it over the interest of 5.8%, and we are done. Now we just did, no, we're not quite done actually. Remember, we have to add that extra month's interest, extra quarter's interest, 1 plus. Okay, very important. Almost forgot there, and it would have been incorrect. Okay, so now we can put this in our calculators. 66411 and 60 cents. Okay. 7.3 says the bank granted Rajesh a loan of 900,000 on the 28th of February 2024 at an interest rate of 6.8% compounded monthly. Rajesh was unable to make the first 3 payments. He made his very first payment on of 10,000 Rand on the 30th of June 2024. He continued to make monthly repayments of 10,000 at the end of each month thereafter. How long in months will it take for him to pay the loan? Okay, so when you're wondering what formula to use with financial maths, just remember P is paying off a loan. That's how I like to think of P as. P is like, he's not paying off 900,000. He's paying off 900,000 plus interest on that of 3 months because he hasn't paid the first 3 payments. So that takes care of that. So let me just put that in there, right? So the 3 first payments, that's taken care of here. Now I can say X is the 10,000. That's how much his payments are. And then it's going to be 1 minus 1 plus the 6.8%. There's no change in interest. Nope. Over 12 to the power of n, or negative n, over 6.8% over 12. And when we simplify that, let's look at what we get. Log base. So just remember this rhyme if you struggle with logs. Log base number. Now, the base is the base of like a basement, something at the bottom. So that would be imply that it has a top. So base number equals exponent, right? Because the logs is a way of getting out our exponent. So that's this thing, negative n here, right? Okay, now the base is going to be the thing at the bottom. So log base, right? So the base is the 1 plus 6.8% over 12, this thing here, right? The number is the number by itself. The number is the number by itself. So that's this thing here. So that's 0. And I have to put the whole thing in here. 48128077798, and that is equal to my exponent, my negative n, right? My negative n. Okay, so we plug this into our calculator, negative 129, which means that n is equal to 129,419,0,321. Okay, now we're always going to round up, remember, because if you pay, even though this is less than 5, so it's 0.4, we're always told to round down when we're young. But now we don't, because if you don't, if you need to pay off this whole loan, so the bank wants all of the money. So it's 130. They always want all the money. Okay, now the final payment is quite a simple formula. All you do, it seems really tricky, is you put in this P formula again, right? The same one. But now where you put an negative n, you're simply going to be put in your this part, the fraction. 10,000 because that was what it was originally going to be. Of course, it'll be a fraction of that, won't it? Because we're going to put in a negative, this. So like it's like basically saying what is this 0.419? If that was a fraction of this 10,000. So it's kind of the fraction of the 10,000 that you're going to have to pay in order to finish off this loan. Okay, so everything the same as before. All you do is you change your minus n to this zero negative, will you change it to, yeah, negative 4190321. Okay, and when we put that in a calculator, we should get a value of less than 10,000. If it's more than 10,000, you've made a mistake somewhere. Minus, and then I get 4173.55. This is right. So that's 7.3.2. And that is financial maths. And I will see you. If this has helped you, please like, subscribe, all that good stuff. I hope I've earned enough in this video to get your subscription and like. If not, hopefully I'll see you in the next video and you can subscribe in that one. Thanks, guys, and I will see you in the next one.